Good evening, everyone. Uh, this is Teams 4 EET 411L Unit 5 Senior Project. And this is done by Team 4, which consists of myself, Maxwell George, and Chris Gilbert. This is our honor pledge stating that all this work is original and done strictly by members of Team 4. In an effort to make our project or traffic scheme a little more efficient, we added an HMI, we added traffic cams, and we added a 7-segment display, which has a 10-second countdown. We also made our traffic scheme dynamic by adding a nighttime routine. We again used PLC as our microcontroller, running RS Logix 500, which we used to set up the ladder logic. The PLC is powered by 110 volts, which also powers all the sensors, including the road sensor. We also used a 5-volt power supply, which powers the LEDs and the 7-segment display. For our program, we again use a single timer with a series of comparators that's tied to the lighting schemes. The timer is set up for 40 seconds, and that comparators is what divides the 40 seconds into the individual schemes. This is a flow chart of the program that we set up. The first 6 slides consist of our original daytime program. Once a program starts, the timer starts. If there's a car at the turning lane or not, if there is, then once the cycle is completed, the turning light turns on. Once a car moves off the turning light, the cycle completes again and then goes back to the original daytime scheme. If you look at the second decision box, that's where we added our nighttime routine, and which goes from 10 p.m. to 6 a.m. And with this one, since the east-west lane is the more busy lane, that light stays green pretty much the whole night. And the north-south lane, which is the least busy lane, stays red the whole night, unless a car pulls up. Once a car pulls up and that sensor is triggered, then it loops back to the daytime routine for 1 cycle to allow the car to move. Once the car moves off and the sensor realizes the car has left, it goes back to the nighttime routine. In setting up the program, we had a hard time at the beginning. We were pretty much banging our heads against the wall because we figured this would have been a straightforward program. We just added the nighttime routine to our daytime routine, but in actuality, that did not work. And it took us a while to figure it out, but we realized what the problem was that with the original program, we had a latch and unlatch when we set up the original timer. So once we figured out that the latch and unlatch was the problem and we removed them from the program, we were able to then add in the nighttime routine and have a smooth transition between the daytime and the nighttime scheme. The latches were preventing us from having a smooth transition from the daytime to nighttime scheme. Once the nighttime was triggered, instead of ending the day cycle, would move immediately over to the nighttime routine, and that's not what we wanted. We wanted that once a night is triggered, we wanted to smoothly end the daytime sequence and then transition into the nighttime sequence. Once we removed the latch and unlatch, we were able to set that up. We were also then able to go ahead and add the traffic cams into the program and the 7-segment display, which is tied to the crosswalks. So the traffic cams are tied to the red lights, so that once the lights are red, the traffic lights are then activated, the sensors are activated. If that sensor is tripped, a white LED would flash, indicating that the camera snapped a picture. This slide just shows the various comparators that were set up to each light. This is where we set up our turning lane, the turning lane light. These are just some comparators that we set up for each traffic light. Same here, same here, same here. And here you can see where we added in the camera into the program, and then we set up a reset at the end of the program to allow us to loop back to the top. And from here, I'll turn it over to Chris.
Thanks, Max. This is our traffic control fixture, our red light as we like to call them down here in the south. This is the whole assembly. This is our HMI that starts the process. This is controlled by Micrologix 1400 PLC. Two modules, our power supply for our HMI, of course the relays that control, switch everything off and on, and 5-volt power supply. And this is how we start our control. This is our start program. So we're going to start the program, and it's going to go into the 40-second cycle that Max has already explained. The east-west is the busier street, so it has a 20-second green light. It switches over. Once it switches over, the north-south can go, but it's a much shorter time than the east-west. So next I'm going to show you our crosswalks. Of course, you can see those. The north-south has a 7-segment display that counts down from 10. And then it switches back. And then we have the crosswalk on the east-west. We have a counter right here on the HMI. So next I'm going to show you the turning sensor. It's in the road for our turning lane. As you can see right now the light's green. The car pulls up when the light's green and activates it. Of course the arrow doesn't come on immediately. We still have to go through the whole cycle, and it's going to have to cycle back around. But when it cycles back around, which is going to be in about 10 seconds, we'll wait patiently. So we got green light, yellow light, and then there's the turning arrow, which is 8 seconds. The car drives on, light's red because the turning arrow is still activated. Once that turning arrow goes off, then you can walk. And it counts it down so you know you're not going to get run over. One of the other features we have is the simulated camera that catches people that run the red light. So now that the red light's on, you see a blue light on that says it's activated. If a car tries to speed past, the light comes on indicating that it got you. And also on HMI it says gotcha. I don't know if you can see that or not. The other feature that we have on our assembly this time is a night sequence, because there's rarely any cars going up and down the north-south street at 10 a.m. or 10 p.m. the night sequence starts, and we activate that with this on the HMI because we don't want to wait till 10 o'clock at night to show y'all this. So what happens is it finishes up the cycle that it's on, and once it gets to the green light on the east-west, it stays this way, and it will stay this way all night long unless a car comes up and triggers a sensor for it to change. So like I said, it stays this way. I want to stay here just for a second so you know it doesn't change. Then say a car pulls up at 2 a.m. and hits that sensor, what happens is it goes back to the original cycle, 40-second cycle. So the car sits there and it waits patiently, probably saying, why ain't this light changing? But then it will. It'll change after the 20 seconds. Now he goes. And then it goes back to the night sequence once that one cycle's up. And it'll stay that way until another car comes up to the traffic light. And this is our project. Traffic light control fixture.